southwesterly flow in the Taiwan area. Basically, I will show some results from from a case study of Typhoon Minduri. This typhoon induced a strong southwesterly flow and brought heavy rainfall in southern Taiwan. To some degree, it is very similar to Typhoon Morakot. And this part of work is done by me and also Professor Chien Lee of National Taiwan University, and also Yiqi Liu, who is now Sua's student in UC Davis. This paper has been published in JMSD in 2008. In addition, I'm going to show some results from a composite study that I and my student Zhu Fang did for the southwesterly flow. And this paper has been published in the Chinese Atmospheric Science Journal. Lastly, I will show some preliminary results from our study. Minduri was a Category 2 typhoons with maximum wind speed about 43 meters per second. And after June 30, 2004, Minduri was moving northward, and it made landfall at 14 UTC July 1st. And then it left northern Taiwan at about 03 July 2nd. And when Minduri was moving northward away from Taiwan, it induced strong southwesterly flow over the northern South China Sea and southern Taiwan Strait, and brought heavy rainfall over southern and central Taiwan on the following days. And this is the abstract from the paper, and I want to draw your attention to this sentence here. Okay. The accompanying strong southwesterly flow brought extremely heavy rainfall over southern and central Taiwan, and this is how we call it when we wrote the paper. However, after Typhoon Morakot, I guess we may not be able to call it extremely heavy rainfall anymore. Okay, on July 2nd, heavy rainfall occurred on the western and southern parts of the island, and the peak values were observed over the high mountains area. And in the simulation, you can see the rainfall agree very well with the observation. And at 31 hours, Minduri was located north of Taiwan here, and there was a convective line over the southern Taiwan Strait at this time. And there was a strong southwesterly flow that converged with the westerly flow here and produced many MCS to the southwest of Taiwan. About 3 hours later, the first convective line moved northward a little bit, and the southwesterly flow pushed all the way to the north, producing another convective line here. And these two convective line structure agree very well with the observation. And the MCS embedded in the convective line just keep moving overland and produce heavy rainfall over the plains area and also the mountain. Now the northern convective line, was a result of convergence between the moist northwesterly flow that came from the low-level typhoon circulation and the westerly flow that descended from higher and outer parts of the large-scale typhoon circulation. And the convergence that produced the southern convective line come from two different air sources. One is from the westerly, and the other one is from the southwesterly that came from the northern South China Sea. These figures show the time evolution of maximum radar reflectivity and long section wind along the 9A here. And time is increasing this way, and this is the distance from southwest to northeast. And you can see the convection developed over the northern South China Sea and Taiwan, southern Taiwan Strait, and move northwestward over time. And they are coincident with the increasing low-level southwesterly flow. And when moving overland, the convection was further enhanced. Now we know that northward traveling typhoon like Niduli can induce strong southwesterly flow. However, the question is, does every northward traveling typhoon come with a strong southwesterly flow? To answer this, we use 56 years of JTWC best track and NSAP analysis data to do a composite study. Using the data, we found 59 cases, 59 typhoons with northward traveling direction after they passed northern Taiwan. And among them, 33 cases are associated with southwestern flow. 26 cases are not. Therefore, the composite is performed for these two groups, the SW group and the non-SW group. And at this time, the typhoon is located about 200 kilometers north of Taiwan. And from the comparison between these two composites, you can see several differences. First, the typhoons in the SW group are stronger than those in the non-SW group. And second, the trough in the southeast China is deeper than in the non-SW group, which results in a strong pressure gradient and southwesterly flow over this area. And moisture was transported to the northeast, all the way from the east bay of Bengal to the Taiwan area. On the contrast, the moisture zone here was broken in the non-SW group. Lastly, the Pacific high extended further westward in this area, such that the typhoons in the SW group tends to move northwestward. However, in the non-SW group, typhoons tend to move northward, or northeastward. And the difference here show more clearly that the SW group has more moisture here and stronger southwesterly flow, which can act like a moisture conveyor belt that transport moisture to the Taiwan area. Okay. Next, I want to talk about Typhoon Morakot. For this study, I used 60 years of best trade data to search for typhoons that have a similar trait as Morakot before and during landfall. And totally, I found 19 cases. And these are the traits of the 19 typhoons. And Morakot is one of them, right there. Okay, next I just compare the translation speeds during 4 time periods, before, during, and after landfall. For Morakot, you can see speed 1 is about 23.5 kilometers per hour. And after that, Morakot moves slower and slower. And during and after landfall, the average speed of Morakot is between 7 to 9 kilometers per hour, which is very slow.